Okay, here's a quick little video on how to do the questions that I gave you on that review. With this one, you could probably type stuff in your calculator, but it's also nice to be able to do it one step at a time. So minus 3 plus a minus 5 would be minus 8. And then I'm just going to write everything else down. Plus 4 plus a negative 7. And then negative 8 plus negative 14 is negative 22. And write everything else down. So one step at a time. Minus 22, add a negative 3. Same sign, add, and keep the sign. Plus 4 plus a negative 7. Different signs, so you subtract, so it'd be 21. Keep the larger number sign. Plus negative 7, same sign, add, so 28, negative. Answer to that one would be negative 28. Number 2, dirty, rotten, filthy, stinking, negative right there. Be careful. So the first one you just leave as is. So 3x minus 3y plus 2. And then here I've got to FOIL that through, or distribute that through to each term in that second bracket. So minus 2 times minus 3x would be a positive 6x. Minus 2 plus 3y would be a minus 6y. Minus 2 times minus 2 is a positive 4. Now collect like terms. The 3x and the 6x are alike, so add those, it's 9x. Minus 3y and a minus 6y is a minus 9y. And then 2 plus 4 is plus 6. There we go. Question 3. I have to solve the equation, so I need to get x's on one side because it's a linear equation, numbers on the other side. So I'm going to add 5x on this side. If I do it there, I have to do it on that side of the equal sign too. So now I have 9x minus 1 equals 53. I want to get numbers on this side, so I'm going to add 1 on this side. If I do it there, I have to add it there too. So now I have 9x is equal to 54. Lastly, I'll use the division principle. So divide both sides by 9, and x, I'll put it down here. So then x is equal to 6. Okay, question 4. Solve. If I need to solve an equation that has denominators in it, I can use the clear the fraction rule. I call it the I hate fraction rule. You first find a lowest common denominator, which in this case will be 6, and then take every term, so 1/3 r, the 2, notice I'm leaving myself room, the 1/6 r, and the plus 4/3. So I'm going to take each one of those terms and multiply it by my lowest common denominator. So 6 times this one by 6 times this one by 6 and times this one by 6. Okay, so 6 times 1 divided by 3 is 2r. 6 times 2 is 12. 6 times 1 divided by 6 is 1. So this will just be 1r, or r. 6 times 4 is 24, divided by 3 is 8. There. Now I have a question just like I had on the one before. So I need to get r's on one side, numbers on the other side. So I'll subtract an r on both sides, leaving me with r plus 12 is equal to positive 8. Then I'll subtract 12 on both sides, leaving me with r is equal to, I'm up 8, I lose 12, I'm down 4. Okay, there's 4 questions. Question 5. Solve, but this one is an inequality, but you solve it the same way as you do all the other ones. We'll get x's on one side, numbers on the other side. This is a negative 11x, so I'll add 11x here. If I do it there, I need to add 11x on this side. I'm down 12, I gain 11, so I'd still be down 1x. Okay, minus 4 greater than or equal to negative 7. I want to get numbers on this side, so I'll add 4 here. If I do it there, have to add it there. So I'm going to be left with minus 1x greater than or equal to negative 7 plus 4 would be a negative 3. Now this has to be an x, not a negative 1x. So I'm going to divide this side by negative 1, divide this side by a negative 1. Now that's the one rule that many people forget, is that if you have an inequality, and if you divide by a negative number, these cancel, all's good, but this sign must switch. So instead of a greater than, it's going to be a less than or equal to. Negative 3 divided negative 1 is a positive 3. Okay, so that's my answer to that one. All right, find an equation having the given point and given slope. Okay, so here's the equation of any line. And I have to come up for this particular thing with what the slope and what the y-intercept are. Okay, they say the slope is negative 4, so I can plug that right in. Negative 4x plus b. But now I got to figure out what this b is. If they give me a point, that's an x and a y value, so I can plug those in for x and y, and then I can solve for b. So I'll put a 6 in for y, and for x I'll put in a negative 3 plus b. Negative 4 times negative 3 is a positive 12, plus b is equal to 6. And then I want b by itself, so I'm going to subtract 12 on this side. If I do it there, I have to subtract 12 on that side. So b comes out to being 6 take away 12 is a negative 6. So I have my slope. Let me rewrite my equation again. So I have my slope from the first. I can put a negative 4 in right there. And I also have the y-intercept, which is negative 6. So I can put that in right there. And then I just leave the y and the x general. There's my equation of that line. Okay, this one says graph using the slope and y-intercept. Okay, so if this is the equation, it's supposed to look like this, right? So if it's supposed to look like that, I've got to change it so that it does. Let me just make my picture a bit smaller here. There, that's better. Okay, so to change it so it looks like this, I'll take 2x minus y equals negative 4. I'm going to move the 2x to the other side, so it'll be minus y equals negative 2x. See, it's positive on this side. On the other side of the equal sign, now it's negative, minus 4. Now I'll divide everything by a negative 1. So divide this by negative 1, this, and this, so every term. So this will be just y is equal to a positive 2x plus 4. So there's my equation, and the 2 is my slope, b, or 4 is my y-intercept, or b. And then when I graph it, that's where I'll start. So the point right there is 4. That's where it crosses the y-axis. And then my slope is 2, which I could write as 2 over 1. And slope is always rise over run. So I can go up 2 and over 1. Up 2 over 1. Up 2 over 1. Or I could have gone down 2 and 1 left. Down 2 and 1 left. And there is my line. So the line will look something like that. Okay. All right, next question. So this one says, determine whether these are parallel, perpendicular, or neither. I have to get each of them into that y equals mx plus b format. So this first one, I have 6x plus 2y equals 8. I'm going to move the 6x to the other side and make it negative. Then I'll divide everything by 2. Y equals negative 3x plus 4. The thing that we're looking at to determine parallel, perpendicular, or neither is what the slope is. So the slope of this line is negative 3. If the slope of the other line is negative 3 too, then they're parallel. If it's not negative 3, if it's something else, then it has to be perpendicular or neither. But let's check what it is. Okay, so here's 9y minus 38 equals negative 27x. Okay, I have to push the 38 to the other side, so it'll be 9y equals negative 27x minus 38. Now divide everything by 9. Ooh, that's an ugly one. Y equals, this will be negative 3x minus, that won't simplify, I'll just leave it as 38 over 9. But notice the slope here and the slope there are the same. Therefore, the lines are parallel. Okay, dirty, rotten, filthy, stinking, negative. I have to apply that to everything there, so let's just rewrite what I have at the first. And I find that rewriting things helps rather than trying to do everything in your head. So the minus means I have to change every sign inside. So that 9 becomes a plus 9. This becomes a plus 4x to the 7th. This becomes a minus 2x to the 8th. this becomes a minus 9x to the 6th. Now I look to collect like terms. I'm going to start with the 8 because that's the highest power. I'll start there. So I have 7 and I lose 2, so I'm at 5x to the 8th. Okay, those are gone. And then 7. Here's a 7, here's another 7. Down 7, and I gain 4, so I'm still going to be in the whole 3x to the 7ths. Okay, here's a 6, and here's another 6. Down 3, lose another 9, so it'll be down 12x to the 6th. Then here's a number, and here's a number. Down 8, gain 9, I'm up 1. There's my answer right there. Okay, number 10. Multiply. This is what a lot of people call FOIL. So if there are two binomials and I'm multiplying, I have to multiply all of it. So this would be 3x squared plus 24x plus 2x plus 16. Often the middle terms are like, and so you can add them. 24 plus 2 would be 26x plus 16. Okay, next one. Oh, this one says to factor. So when you factor anything, what you first want to do is look for a common number or letters that will divide evenly into all of these. It looks like 4 will go into all of them, and it looks like m squared is the most I can take out. So I'm going to factor out of 4m squared. This step you don't have to do, but it's not a bad one to do, just so you don't mess up too much. So you take each term inside here and divide it by whatever your lowest common denominator or lowest common multiple is. So plus 20m squared divided by 4m squared. Okay, so I have 4m squared outside. Here, 32 divided 4 is 8. M to the 7th divided m squared is m to the 5th. For the next one, I'll get 3m squared, and the last one plus 5. Oh, the m's cancel. Plus 5. So there's my answer. Okay, next question. Factor using the AC method. Oh, that AC method. So I have to multiply the A by the C. So it's 6 times 2 is 12. So I'm looking for two numbers that multiply to 12 and add to 7. Add to 7. 3 and 4 has to be. So I replace the middle term with 3 and 4. So I write it as 6x squared plus 3. Now you have to keep that same thing in there. So xt plus 4xt. So there's my 3 and the 4 that I figured out over here. Plus 2t squared. Now I group factor. So I think I can take a 3 out of here and maybe an x. So I'll be left with 2x plus t. The next one I can take a 2 out and a t. So I'd be left with 2x plus t. Now if these are the same, I can continue. They are. So I can factor those out, write them out front, 2x plus t. So they're gone, and I write what's left over, 3x plus 2t. There we go, factored. Okay, solve by factoring using the principle of zero product. So now I've got an expression, but it's equal to something, so this is an equation. So what I'm looking for is the values of x that make this statement true. An easy way to do it would be to factor it. So I'm looking for two numbers that multiply to negative 24 and add to positive 2. So multiply to a negative 24 and add to a positive 2. I'm thinking a positive 6 and a negative 4. They multiply to negative 24, they add to 2. There's my numbers right there. So x plus 6, x minus 4. Then they say use the principle of zero product. So if I have two things that multiply together to give 0, one of them's got to be 0. So either x plus 6 is 0 or x minus 4 is equal to 0. Solving this one, subtracting 6 from both sides, I get x equals negative 6. On this side, adding 4 to both sides, I get x equals positive 4. So those are my two answers for that question. You can check those too. If you plug the numbers back in, you can check to see if they're correct. Okay, now it says subtract. there's not an equation sign here, so I can't use the I hate fraction rule. So if I have fractions and I'm asked to subtract, I have to get a common denominator. First thing will be to factor that one. So that's a difference of squares, so it's x minus 5, x plus 5. Okay, minus x over x minus 5. Now, to get the common denominator, this one has an x minus 5, so does this one. This has an x plus 5, but that one doesn't. So I need to multiply both top and bottom by whatever this one doesn't have. So it doesn't have an x plus 5. So I'll do that on the top and the bottom. Now they both have the same denominator. I can write them all over that denominator, x minus 5, x plus 5. And then I just write the top stuff together. So it'll be 8x minus x times x plus 5. On the top there, I should simplify that. So 8x, okay, minus x times x is a minus x squared. Minus x times 5 would be a minus 5x. All over that same thing. And then I notice on the top that I have like terms. The 8x and the 5x are like. So I can combine those. So I'll leave the minus x squared out front. And then 8x take away 5x would be a positive 3x. All over that same denominator. Okay, those are tough. Rational expressions are tough. Oh, here's another one right here. Oh, but this one's an equation, so I get to use the I hate fraction rule. First thing that I want to do is I need to get a common denominator. But in order to do that, I need to factor this guy. So this will be over, and it's a difference of squares, so it's m minus 3, m plus 3. So the lowest common denominator appears to be this, because both of those are included there. So this part here is the lowest common denominator. So I'm going to take this term and this term. Notice I'm leaving room. And this term. Notice also you have to do it to every term, not just to the ones on the left. I'll take each of those terms and I'll multiply it by the lowest common denominator, which is m minus 3, m plus 3. And this one, m minus 3, m plus 3. Oops. And this one, m minus 3, m plus 3. Okay, here the m minus 3 cancels, so I'm left with m plus 3 times 9. I'll write the 9 first. M plus 3. Okay, next one, m plus 3's cancel, so I'm left with this. Again, I'll write the 6 first. So minus 6 times m minus 3. Notice dirty, rotten, filthy, stinking negative. Equals, all of the top and the bottom cancel except for that 9. Okay, now I've got an equation that I can multiply through and solve. So this would be 9m plus 27, and then a minus 6m plus 18 is equal to 9. Now I want to get the m's together, so 9 minus 6 would be 3m. 27 plus 18, that's got to be about 45, is equal to 9. Now let's subtract 45 on both sides. So I'll get 3m is equal to whatever 9 take away 45 is. 36, I think. Oh, it would be negative 36. Now I'll divide both sides by 3. 36 divided 3, I think, is 12. So m is equal to 12. When you're dealing with rational equations, you always want to take what your answer is and plug it back in to make sure you don't get a 0 on the bottom. Negative 12 minus 3, negative 15. Yeah, I'm not going to get a 0 on the bottom. Therefore, this answer's correct. Okay, almost done. Radicals. So I need to multiply these. If it's all multiply here, I can multiply and just multiply the things that are the same. So 3 times 6 is 18. X squared times x cubed would be x to the 5th. Y times y to the 6th would be y to the 7th. Now I can see if I can simplify this. Remember all those perfect numbers, 1, 4, 9, 16, 25, etc. I want to see if any of those will go into 18. Sure enough, 9 does. So I can rewrite this as 9, or I could write it as 3 times 3 times 2. That gives me 18, right? And then x to the 5th would be, I'd have 5 x's. Y to the 7th, oh great, 7 y's, 4, 5, 6, 7. And then like we talked, you can, in class, for every 2 things inside, you can bring 1 out. So there's 2 3's, I bring 1 outside of the radical. Okay, and then these ones are gone. There's only 1 2, let me put my radical sign here. There's only 1 2, so it's stuck inside. Okay, here's 2 x's, and I bring 1 out, so these are gone inside. There's another 2 x's, so I can bring another x out, and those are gone. But there's an x there by itself, I'm stuck with it. Again, y's, there's 1, 2, 3 y's that I can bring out, and I'm stuck with 1 y inside. Now, if I have 2 x's like this, I'll probably write it as 3x squared, y cubed, and then the square root of 2xy. Okay, there's multiplying radicals. Okay, dividing radicals, I would probably simplify this thing first before I started to try and bring things out. So this, I could really rewrite it like this, 3t to the 22 over 75t to the 6. Well, 3 goes into 75 5 times, or 25 times. So I can rewrite that as t22 over 25 t6. I can do the same thing here. T to the 22nd divide t to the 6th, dividing common bases, subtract their exponents. So that would be on the top. 22 take away 6. What's that? 16? T to the 16th over 25. Now, using the same rule as I did here, but backwards, I can rewrite those separately. So the square root of t to the 16th divided by the square root of 25. Square root of 25 is 5. Square root of t to the 16th, if I have 16 t's inside, I could take 8 out, and I'd be left with none under the radical sign. So that would be my answer. Okay, here's one where I'm adding radicals. If I add radicals, I have to get the radicand to be the same. So I got to figure out one of those numbers, 1, 4, 9, 16, 25, etc. that'll go evenly into that. I wonder if 36 will. 108 divided by 36. Well, let me just guess. Is it 3? 36 times 3, that'd be 18, 1. Yeah, that's right. So 108 is the same thing as the square root of 36 times the square root of 3. Okay, which I could simplify to minus 6 times square root of 36 is 6 times root of 3. And negative 6 times 6 is negative 36 root 3. Now I want to do the same thing to this one. So I have plus 7. Okay, 192. And I got to pick one of these numbers. Now 49 is another one. I don't know. Will 3 go into that? This one had a 3. Let's see. 192 divided 3. 3 goes into there, 6 with 1 left over. 3 into 12 goes 4. 64. Yeah, that's it right there. Because if you keep going, 7 times 7 is 49, 8 times 8 is 64. It's one of those pretty numbers. So this would be the square root of 64. I shouldn't have made that long. Times the square root of 3. Or the square root of 64 is 8 times the square root of 3. 7 times 8 is 56 square root 3. Now I've got a question where I've got the same radicand. So now I can add or subtract the first ones. Down 36, gain 56, I'm up 20 root 3's. Okay, number 19, solving a radical equation. You need to isolate the radical. Once the radical is isolated like it is here, I can use the property of squares. So I can square that side, but if I square that side, I have to square this side. Squaring a square root, they cancel, so I'd be left with p squared minus 3p plus 81. And on this side, I have to remember that I have to write those 2 out and then FOIL that out. So it'll be p squared minus 3p plus 81 on the left side. On the right side, it'll be p squared plus 6p plus another 6p, so that'd be plus 12p. And then 6 times 6 is 36. Okay, p squared the same on both sides, they cancel. And then negative 3p, why don't I subtract 12p here, and I'll do that on this side too. So I'll get negative 15p plus 81 equals 36. Then I'll move the 81 to the other side. So negative 15p is equal to 36 minus 81. Okay, 36 minus 81, that's about 45. So negative 45 equals negative 15p. Now I'll divide both sides by negative 15. And I'll come up with p is equal to a positive 3. Always check, put the 3 back in, see if you get a negative number under the square root sign. 3 squared is 9. 3 times 3, that's another 9. 9 minus 9 is 0. 0 plus 81, it's not a negative number. Therefore, this answer is correct. All right, last question. Find the length of the third side. So I'm looking for this side. Pythagoras is the rule that we want to use to solve this. C is always the longest side. So that's 26. So 26 squared is equal to, we'll say this is A, 20 squared plus B squared. Okay, 26 squared. Gee, I don't know what that is. Calculator. So 26 times 26, 676. Oops. So 676 is equal to 20 squared, that's 400, plus b squared. Subtract 400 from each side, so I have 276 equals b squared. Now I can square root both sides. Square rooting this just gives me a b, and on this side I have to figure out what the square root of 276 is. So 276 square root me. 16.6 about. Okay, so this is 16.6. Okay, that's just a quick answer key, video answer key to that review that I gave you. Hopefully it helps some.